All right, we are going to construct a triangle that is going to have side lengths 4 centimeters, 5 centimeters, and 6 centimeters. So if you're watching here, we're going to start with the longest. So start with, I'm going from 0 to 6 centimeters, if you can see that. All right. From there, I'm going to use this compass to measure out. We're going to do 5 centimeters and 4 centimeters. So 5 would be from here to here. Let's see. So going from 0 to 5. Okay. And then this is I'm going to try to indicate where is that going to be. It's going to be out here somewhere. Okay. So that's going to be 5 centimeters from here to wherever that lands. Okay, and then, so that's the 5. We have, this is 6, and now we're going to do one that's 4. So that's going to be from 0 to 4. All right, 0 to 4. Okay, so this is going to help me figure out where are these lines going to meet. So that's where it's going to happen, right at this point. This is the meeting point. All right, so then from there, I'm going to connect these. Hopefully, if I measured it right, it'll be right at 5, which it is. Okay. And then I'm going to connect. This should be 4 centimeters, and it is. And then I've got my lovely triangle that was 6 centimeters, 5 centimeters, and 4 centimeters. So we were able to do that. All right, let's try another one. So 9 centimeters, 3 centimeters, and 5 centimeters. What is going to happen here? So start with the largest. I'm going from 0 to 9. Okay. Then again, I'm going to measure out. We'll do 3 and 5. So maybe start with the 5. I want to measure my compass to be 0 to 5. It's pretty close. And then I'm going to do the same thing I did before. Go right at the edge here. And then that's going to show me. Try again there. Where that 5 centimeters mark. Not perfect, but I tried my best. Okay, then we're going to measure out 3, and we're going to see what happens here. And what we see is that these are not connecting. I'm not going to get to a point where the 3 and the 5, let me try that 5 one more time. 0 and 5. So if we were together in a classroom setting, we would be, is that right? 0 to 5. Try to get that. I didn't do it perfectly the first time, it looks like. So we would be trying this together, and we would see that the 3 and the 5 are not going to meet. And then you would be trying to figure out, well, where is that meeting point? It doesn't exist. And then this kind of discovery activity is that this triangle of 9 centimeters, 3 centimeters, and 5 centimeters is impossible. We cannot have a 9 centimeter and then a 5 centimeter and a 3 centimeter side length. The sides will try to meet, but they're not going to be long enough to meet. So that is the kind of the discovery task here, that you'll learn that some triangles are actually not possible. And then the question would be, okay, which triangles are impossible? Okay, then you would think that through, and it has something to do with this 3 and this 5 not being long enough to where they're going to be able to meet. So with that, we learn a property from that, which I'll talk through. So what you should learn is the triangle inequality property. What does that mean? The sum of the lengths of any two sides of a triangle must be greater than the length of the third side. If we went back to that other example, 3 plus 5 is only 8. So it's not going to sum up to this whole distance. So these two sides can try to meet, but they're not going to be long enough. So what does that mean? The sum of the lengths of any two sides need to be greater than the length of the third side in order for the triangle to be possible. So if you look at your PowerPoint presentation on Brightspace, it's following along this this same kind of outline that I'm going through right now. So is the triangle possible? You would say 2 centimeters, 4 centimeters, 5 centimeters. Well, take the two smaller sides, right? 2 and 4, add them together, right? You'll get 6, which is greater than 5. So yes, this is going to work. Does that make sense? So you would say, is the triangle possible? Yes. Unlike this one, I've got 2, 4, and 8. If I add up the 2 plus the 4, I get 6. 6 is less than 8, right? So this is not going to work. It's going to be like this situation where those two side lengths will not be long enough to connect, right? So you would say, no, this is not possible. Okay, so how can I use this triangle inequality property? All right, we're going to have 4 towns, Abbott, Bronzeville, Connell, and Davis, are building a new power plant. We've got Abbott, Brownsville, Connell, and Davis are going to build a new power plant. They need to connect power lines to all 4 towns. To keep the cost at minimum, they would like the shortest distance of power lines possible. The towns are located at points A, B, C, and D. Use the triangle inequality property to explain why point M is the better location for the power plant, as opposed to point E. All right, so you might study this for a while, and I encourage you to pause the video and try to think about it, okay? But what we're going to do is visualize some triangles here. So what we know from the triangle inequality property, this line here, BD, okay, and then this line DE and this line BE is going to create a triangle. And because of the triangle inequality property, I know that DE plus BE has to be greater than DB. Okay, so I can say DE plus BE must be greater than DB. All right. What else? There's also this AC, right? So this is, I'm kind of losing it with the colors here. This blue line, okay, is my AC. And then I've got this triangle, AE, okay, and then CE. So I know from the triangle inequality property that AE plus CE, okay, is going to be greater than AC. So what you'll notice here is on the left, I had DE and BE, okay, that was DE and BE. Those were the red lines. I almost should have printed another copy so that we could go back to the color. These were my reds, right? The distance from the town to point E, and then this town to point E, and then that has to be greater than the blue of which was DB, right? And that's going through point M. Okay, so I've got basically my red lines are greater than the blue line. Then going back, AE and CE, again, those are the leading to point E. AE and CE, these are my reds. They are greater than the blue, which was AC. Okay, so essentially we just proved that adding up all the red will be greater than the blue, which goes through point M. I almost want to like erase so you can see the colors, right? So we just showed that the blue lines were shorter distance than the sum of the red lines. So hopefully that makes sense. And then there's actually a PowerPoint slide that lays this out probably neater than what I just did. So make sure you go to the PowerPoint and take a look at how they explain it. I guess yeah, I'm gonna pause right there. So to conclude, these were my red lines, right, that go through point E. Okay? And then these were my blue lines, which go through point M. So we just proved, now let's add up everything on the left. I know that DE plus BE plus AE plus CE, so those are all the red lines. Okay, I know those have to be greater than if I added up the blue lines, DB plus AC. So in the end, we just proved that the red lines sum up to be more power cables than if I summed up the blue. And the whole point of this was to use our triangle inequality property to show that the power lines would be best if they'd be smallest, the smallest amount of cord if we went through point M instead of point E. Hopefully that makes sense. Triangle inequality property for you all.